Hello everyone, welcome to this video. In this video, let's see this question which states that if A is a group element and A has infinite order, then we need to prove that A raised to power m is not equal to A raised to power n whenever m is not equal to n, right? Now we are given G as some group, right? Let's take some element A from it. Now we are given that the order of A is infinite. What would it mean? It would mean that there does not exist a smallest positive integer n such that a raised to power n is equal to e, correct? This is one thing. Another thing, we have to prove that whenever m is not equal to n, a raised to power m is not equals to a raised to power n. So we assume that m is not equal to n. So that means one of them is bigger and one of them is smaller, right? So we assume that m is less than n. It would also prove the other way around, because these two elements, they are just the arbitrary elements. So the role of them could be reversed in this case. Hence, only one case is required to be discussed in this particular case, right? Okay, we assume this thing. Now what we wanted to prove? We wanted to prove they are not equal to each other. So we'll be using the method of contradiction, as in most of the cases we do. Right? In contradiction, we assume if possible they are equal to each other. If they are equal to each other, we can post multiply both sides with a raised to power minus m, so that we would have this. So you can write this term as a raised to power m whole raised to power minus 1. There is no issue. And here, by the laws of exponent, you can combine the powers. It would be a raised to power n minus m. Right? Now you have the element and its inverse here. So it becomes the identity element, and moreover you see this is a positive integer, right? So you have obtained the power of a, which is some positive integer, and this would give you identity, right? So that means this n minus m becomes the order of a, correct? Which is a smallest positive integer of such kind. Thus we found a positive integer n minus m such that a raised to power n minus m would become identity. So this is a contradiction to the given condition, because a is given to be having an infinite order. If that is so, therefore whatever was as assumption, it was incorrect. We have assumed already that a raised to power m was equal to a raised to power n. Now this thing is not true. This thing is not true. So we have our result which we wanted to prove, right? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.